Hello all, myself Prachi Agarwal, Assistant Professor in Akgec Engineering College in the Department of Electronics and Communication. My topic for today's lecture is lithography. The topics I will be covering in this lecture is lithography, optical lithography, the types of photoresists, photomask, what is photomask, steps involved in optical lithography, advantage and disadvantage of this particular optical lithography, then there are various applications of optical lithography, then another type of lithography, that is electron beam lithography, and advantage and disadvantage of electron beam lithography. So first of all, what is lithography? Lithography is basically the transferring of pattern from one device to the particular another. So like we say the example of rangoli, the way we are transferring the design of rangoli to the floor or the different thing. So the same way we are doing here in Vlsi, we are making the particular designs on the substrates with the help of lithography. So this I have mentioned, the technique of transferring geometric patterns using a mask to a thin layer of radiation sensitive material. Radiation sensitive material means that suppose this is a substrate and we need to transfer some kind of pattern into it, over to it, right? So we need to make this surface, particular surface, capable of taking that particular you can say those patterns. So for this we have to apply photoresist on it. So the covering rest of the surface of a semiconductor wafer is known as lithography. That means we are transferring the pattern from one particular device to a substrate with the help of some photoresist. On applying of some photoresist, this is lithography, right? So lithography is basically of two types, optical lithography and we say that electron beam lithography. So lithography is what? It is a transfer of pattern and it can be done by two ways, optical lithography and electron beam lithography. So in optical lithography, it is a crucial process in the production of semiconductors, because it is all about the making of certain patterns, and the patterns can be formed with the help of optical lithography, with the help of lithography. And when the word is optical is added to the lithography, that means we are using some kind of rays. We are using this is a suppose substrate, right? And we need to transfer some kind of pattern to this. We need to make this pattern here, right? So this pattern, the transferring of this pattern over to substrate is lithography. Now we are transferring this pattern to substrate in the presence of some kind of light rays, right? So with the help of this light rays, this transferring of pattern is known as optical lithography. So when this transferring is happening with the help of some kind of photoresist, there is some light material is there. So this transferring is known as optical lithography. So the main thing in this lithography is, we can say, the photoresist. Photoresist is the important thing, you can say. Second is photomask, right? So and third is the presence of any light device. Right, light device means in the presence of something on which the transferring is happening, right? So after that I have already mentioned, after that UV light, ultraviolet light is passed through a mask that contains the desired pattern. So this is the pattern, and this pattern is basically in the drawn in the mask. So mask is particular thing on which that particular pattern is there, right? So apply to the resist coated wafer. Resist coated means this is a wafer, and first of all we have to coat this resist with some kind of photoresist so that it can become capable of taking those patterns. So this is photoresist, which I told already. The substrate is the base thing, our substrate, right? So on the substrate we have applied some photoresist, the layer of photoresist, then photoresist, and then we have applied some, we have taken some kind of masks. The mask I have shown here, these masks, right? and this from the yellow I have shown the light, the UV light. So when the UV light does fall on this mask, right, so what happens, this photoresist is there. So photoresist actually is of two types. So it is positive photoresist and we say negative photoresist. In the positive photoresist, what happens when the UV light is falling on the substrate, on the particular, you can say that photoresist part. So positive photoresist, basically the exposed part of the photoresist help it will get it will be taken out in the case of positive photoresist, and in the negative photoresist, the exposed part, this one is the exposed part, this will remain here, and rest of the part which is already covered up with the mask is basically clear off. So it is of two types, positive photoresist and negative photoresist. In the positive photoresist, the exposed part becomes soluble and it will be taken out. So this is the exposed part. So in positive it is taken out, right? Here I have shown. And the negative part, the exposed part, this is the exposed part. So this is only here left and rest of the part is taken out. So this is positive photoresist and negative photoresist. So it may ask you what is PR. So in the PR also you have to write about photoresists. So types of photoresist, the definition I have quoted here. Positive photoresist is a type of photoresist in which portion is exposed to light and becomes soluble to the photoresist developer, right? The unexposed part of the photoresist remains insoluble in the photoresist developer. Clear? So the same way I have shown that this is a substrate, and suppose this is a layer, and when some kind of mask is there, so when UV ray fall in it, the exposed part, this exposed part basically will taken out in positive part, and in the negative part this will remain, and the part which is there, which is covered, is taken out. So in the negative photoresist, it is a type of photoresist in which the portion of the photoresist that is exposed to light, this portion that is exposed to light becomes insoluble in the photoresist developer. The unexposed portion is dissolved by photoresist. So this becomes dissolved by photoresist, right? So the same I have shown here. The positive, the exposed part is taken out, and here the exposed part is kept. The same, the exposed part, this is this is basically what, this is the pattern. The same way the pattern, we need to, pattern is basically the, you can say, the covered up by mask. Clear? So this is the types of photoresist. Now the another topic is photomasks. Photomask, this is also very important topic in the lithography. So photomask is the particular, it is a mask which is an opaque plate with transparent areas that allow light to shine through in a defined pattern, right? So there is some device on which you can say the pattern is there. So pattern is like some part of the pattern, some part of that particular mask is opaque, and some has been made transparent so that transfer can become easy. So in the case like I have told the example of Rangoli, we use particular stainers, we use on which the design has been made, we use cardboard on which the design is there, and from there those cardboards we use to transfer those patterns to the floor or to the particular area where the Rangoli has been made. In the same way in the lithography, the pattern is basically, we are not going to draw the patterns, the pattern is basically done, that can also we can done, but the easiest way is by the using of photomask, because we have to make chips, and that there is particular defined photomask is there on which pattern is defined, and from that particular photomask we are easily applying those pattern to our substrate. That I have shown here also, that this is the photomask and this is the substrate. So on the substrate, with the help of photoresist, we are transferring the pattern, this pattern, over to our substrate, right? So this is photomask. They are commonly used in photolithography for the production of integrated circuits, ICs, to produce a pattern on a thin wafer material, usually silicon, right? So these are some steps involved in photolithography. So the first one is substrate cleaning, that there is a wafer, we have to clean this wafer, we have to coat this wafer with a photoresist, right? Then there is pre-bake option is there, so that particular that you can say the uniformity is there. When you are applying some kind of photoresist, it will become uniform over the substrate. So pre-bake is the word we are using there. Then that is the align and expose. It is basically the when the mask is kept over your photoresist over your substrate, the mask is kept and it is exposing to the UV light, right? Then afterwards we have post exposure bake. Post exposure bake, bake is the word where we are basically defining the uniformity, right? Uniformity over our substrate. So when we have applied the UV light and we with the help of some kind of photo mask, so there also we are transferring the pattern. So again we need some kind of baking, some kind of uniformity. So the substrate is warmed again to balance out the example in the photoresist. To balance out, you can say the extra photoresist will get take it out. We can take it out particular. Then we have developed with the help of positive photoresist and negative photoresist, we have developed this structure. Then it is the last, etching and implant. Etching basically is to remove the extra material, or we can say the uncovered substrate are carved out. So that is the etching process. And then we have strip resist. Implant is another important topic, so that we will cover later. But here you can understand implant is used basically for doping, and doping is used for to increase the electrical properties of particular thing where we need that kind of doping. So in this step we generally do etching and implant, the whatever required to us, right? And the last is the strip resist. So we just take out the extra part, the same we have done in the etching. So the patterned substrate is left behind after the remaining photoresist is removed. So whatever photoresist we have applied initially, and because that we have applied only for the transfer of our pattern. So when the pattern got transferred, so the use of photoresist get over, and then at the last step we will remove it out with the help of etching. So these are the all steps, and these steps are very important. That what are the different steps involved in optical lithography, right? So again I have shown here, this is metal, this is substrate, and this is some kind of metal, and on the metal we have applied the photoresist. Then this is photo mask, and we are transferring the pattern. The pattern has been transferred, right? So this is basically you can say you can say with the help of positive photoresist and negative photoresist, pattern got transferred, and then this is finally etching has been done, and we have removed this photoresist. This is photoresist part. So this has been etched out in this step. So in the last we are left with the desired substrate and with the desired pattern, right? So these are the different steps which we are going which we have done in the optical lithography. Then advantage of lithography, optical lithography is high quality patterns. We all know the patterns are of very high quality because we are using the prefix design photo mask. So there is no chance to get any kind of you can say error or something. So this creates a precise and the detailed patterns on various substrates, right? Efficient production. So efficient production means it is effective in mass production. We can get large number of productions by using such type of lithography patterns. Then we have cost effective. Cost effective means it is relatively affordable to make more items, because there initially it is requiring one, you can say that initially one type of mask is required, and that mask can be used various time. So it is cost effective in that sense. Then versatile, it can be used with different materials including metals and plastics. Accurate alignment, it ensures that all parts fit together correctly, right? Then we have fast processing, it enhances the pace of machine working, which increases the production speed. So these are the advantage of optical lithography. Then disadvantage of optical lithography, the size limits. It can be also known as photolithography. So it faces drawbacks in making extremely tiny structures due to the type of light it uses, because the light it is using UV light, right? And the structures which we are making with the help of photo mask in the presence of light, they are basically of small size, so tiny structures they are particularly making. Then they have a, complex process. Complex process means because we are using some photo mask, we are applying photoresist, we are using photo mask. So there are various, you can say, then we have to etch the extra material and we have to strip it off. So certain kind of steps are required. So that is why we say that it is more complex as compared to there may be another processes, right? Then expensive equipments, the necessary machines can be costly, special clean rooms are needed. Costly pattern design, it proves to be expensive in creating custom designs, especially for unique templates. So when there is a requirement of particular design, so for that case the mask need to be prepared in the different way. So as per the requirement, custom designs are there. So it may impact some kind of cost, overall cost, so that makes it some expensive as compared to other methods. Then there is the environmental concerns. Some of the chemicals and processes used in this process can impact environment if not handled properly. So this is the point which we can basically use in any of the process, because here in these processes we are using various chemicals. So these chemicals are hazardous and they may impact to the environmental conditions. So this we can quote in the disadvantage of lithography, right? So then applications, in the application we all know in semiconductor manufacturing, in the electronics industry, for the circuit boards, the PCBs, optics, it is used in the production of lenses, optical devices, right? So medical devices and nanotechnologies, because all the things which we are basically, we can say we are seeing near among us. So it is basically it is made up of chip and made up of VLSI, using VLSI. So that is why these patterns we are requiring, because if we are using phones, so that is also using some kind of chips. So the chips, the pattern is there. So this pattern is basically made up of using lithography. So we can say that it has various application in every field. Almost all the fields has been covered. So these are the some of the applications I have quoted here. So the another type of then lithography is, you can say, electron beam lithography. It is also called EBL. It is a technique for creating high resolution pattern on semiconductor substrate by directing a beam of electrons to selectively modify a thin layer of electron resist, right? So in the electron beam lithography, what is there? First of all, in the optical lithography, what we have seen, the substrate is there and we are covering it with some kind of photoresist, PR is there, and then we are using some photo mask, the design which we are basically need to get on our substrate. So we are using those photo masks and we are applying some kind of light rays to it, right? So in this electron beam lithography, this will not going to happen. In this we are not using any kind of PR, photoresist we are not using in electron beam lithography. So this is the one difference you can quote in this. And also there is one major difference, that we are getting the pattern directly with the help of electron beam here. So directly some kind of, you can say, device is there and this is your substrate. So we are getting the design with the help of this method over to our substrate. So there is no light rays, there is no requirement of any kind of photoresist, right? So although in place of photoresist we are making our substrate with capable of taking the electron, because in the electron beam lithography it is done with the help of some kind of electron, beam of electrons. So we are making our substrate that can be capable of holding those electrons, right? So we can say that we are covering our substrate with the in place of photoresist we are covering it with the electron resist. So this is the difference, right? So here I have quoted the steps. First one is the substrate, same we have done in the optical lithography. Then there we have used photoresist, but here we are using electron beam resist, right? So then electron beam is falling on this resist. There we are using basically light rays which are falling, UV light rays which are falling on it. But here what is happening is electron beam is falling over to it, and then with the help with the help of this we are getting developed the transfer pattern is getting developed, and then this is a deposition I have shown, metal deposition, and the stripping of resist with the help of that same process, etching. The extra material, extra photoresist will get stripped off, right. So the methods I have shown: substrate preparation, resist coating, electron beam exposure. The heart of EVL involves a machine with a special electron gun. So there is a use of electron gun. With this gun basically it generates, you can say that there is a gun which basically generating the beam of electron. So electron is there, and here you can say the substrate is capped here. So with the help of this the pattern is getting transferred over to the substrate. And there we are using some lenses also, because when the electron is falling on the substrate, there may be chances that those electron will get diffracted and they may change their path. So we have a limited area given to the substrate. So electron beam cannot move here and here. We have to move our substrate to a where we are requiring the you can say that pattern. So that is why basically we are using some kind of lenses also to particular make it the beam. And apertures. So development same, it develops the pattern of electron, defines on the resist layer. Then pattern transform, that is optional. A subsequent etching step can be used to transfer the pattern. Here we can say from the resist onto the underlying substrate material. The same way which we have done in the for optical lithography, the same we are stripping out the extra material with the help of etching, with the process of etching, right. So this is the diagram of optical lithography, internal structure, how the electron beam is generating. So this is a source of electron beam, right. So where first we are using the condensed lens. The lenses, different types of lenses. In the 2 and 3 stages the lenses are used. Lenses are basically used to make it a particular to make it like it will not get diffract to another place, it will not deflect to another point. So that is why we are using the lenses. The beam banker also the same process to make it a particular beam, so that it can be passed through the aperture. Aperture is also the when the beam of electron is transferring over to the lens, and then finally this after this lens basically the pattern is particular, you can say this is a same electron beam is there, and we are transferring the pattern over to the substrate. So in this case this whole device, you are seeing this whole device is moving, but it moves only very very slowly, and it cannot move over to the substrate. So we need to move the substrate. So this substrate is basically capped over the table, and from the table this substrate keeps on moving here and here, and then suppose you have to make some pattern over here, and then after after completing this you have to make here. So particular you cannot say that this electron beam will come here and you will get the pattern, although you have to basically displace your substrate over to that place where you need the pattern, right. So this is the structure of electron beam lithography. So it has the main parts, it is using different kind of lenses so that your electron beams will not get deflect, and it is using aperture also just to make the transfer of electrons easy to over the lens, right. So this is the advantage of advantage and disadvantage of electron beam lithography. Ultra high resolution, the unmatched precision makes it ideal for cutting edge research in nanotechnology. We all know that these processes which we are studying is basically for creating the miniature structures which we will be using in our VLSI, which we will be using in nanotechnologies. So it is making high resolution structures. Maskless flexibility, because here we are not using any kind of mask as we were using in the optical lithography. So this is the difference, that there we were using photoresist, there we were using photoresist, but here we are using electron resist, right. There we were using photomasks, but there is no photomask, we are transferring the pattern directly. So this is the difference, important difference you can quote from the optical lithography and the EBL, right? Then environmentally friendly, it avoids the use of harsh chemicals. In this we were using chemicals, so there is the use of chemicals, there is no use of chemicals, right? So then the next topic is disadvantage of electron beam lithography. In the disadvantage, we have seen that slow and impractical, that EBL process is quite slow as compared to other process, because it is basically focusing on high precision. So when we talk about the high precision, the precision can be you can say that it is related to the speed. So when if we can say we are requiring a good thing, so it may require some time, right? The same way when it is talking about high precision, that this can be done with the, you can say, slow speed. So here the work which are developing is quite slow as compared to the another process. So the beam point by point scanning makes it slow process and unsuitable to the high volume manufacturing. Since the pattern is transferring, the suppose we have to make this pattern, right? Suppose we have to make this pattern, so it is done with the help of this beam. So this beam and this table, this substrate is kept over the table, so this is moving, right? So you can say that here we are not using any kind of photo mask. So photo mask is something, if we the same example I will quote again, the rangoli example. The rangoli can be done when we are directly drawing the rangoli with our hands, and it can also be done with the help of some kind of, you can say, the design made on a cardboard or a strainer, right? So we will see that we have seen that with the help of those strainers or those cardboard fitted designs, the making of rangoli is quite easy, right, as compared if we are going to draw it with our own hand. So it is a, I mean, long process. Although the pattern, the rangoli which we draw with the help is more beautiful as compared to the pattern one, because there we are using the design on our own way, and in the photo mask, with the help of some kind of cardboard designs, or we can say some strainer, the designs are already prefixed, so we cannot make or we cannot edit those designs. The same way in this EBL and the optical lithography. Optical lithography is basically with the help of photo mask, so their design and the speed is fast. But here what is happening is the design and the speed is basically, I mean, you can say that speed design is also, you can say, slow process is there, and the speed also we can say the slow speed is there, because it is basically making the pattern with the help of, in the rangoli, with the help of hand, and here with the help of some kind of beam of electron. So that beam of electron is creating the pattern on each and every substrate. So this is a quite expensive and complex process also, right? Why? Because it involved a high vacuum environment, because this all process require a high vacuum environment. So the setup, due to this setup becomes complex. Then susceptibility to errors. The focused electron beam can be affected by forward and backward scattering, leading to inaccurate in the final pattern. The same way, because we have used some kind of, we have used basically three levels of lenses, right? So lenses are required just because of this, because it is a long process. So focused electron beam is required. So to make it focus, we are using some, lenses on various stages. So because it is, it is prone to errors, right? So this is the disadvantage of electron beam lithography. Earlier we have talked about the optical lithography, advantage and disadvantage, and the same we have talked about this. So I think the things are clear to you, and you can able to answer the process of lithography, different steps involved in optical lithography and electron beam lithography. What is photoresist, positive photoresist and negative photoresist, right? And the significance of photo mask, the different steps involved in the electron beam lithography, and the importance of all these topics. So I think these all topics are covered to you. And this is, I mean, I assume that this is now clear to you. So thank you and Jai Hind to all of you.